when we talk about data modeling and the tools, I mean, I would just like to tell you before I go ahead with the course, it is very important to understand the concepts and basics of data modeling. And working in a case tool is just, I mean, if you get a bit of hands-on, I mean, whether it is Erwin or whether it is ER Studio or whether it is Sybase Power Designer or any other data modeling tool, it is the same technique. You will be creating same set of diagrams. So it is more of a process that you need to understand of how you go about creating a data model. Okay, so before we get into the process of practically creating a data model in a data modeling tool, we will talk about what a data model is, why it is required, and all those stuffs. So here, when we talk about data modeling, I will not really get into an OLTP data modeling or a data warehouse data modeling straight away, but let us first understand in the IT setup, why do we really need this technique to manage the data? So from information management perspective, we will try and understand why data model is very important. Okay, we will first discuss like what are the challenges that we have today in the IT world in terms of information management, and then we'll go about why do we need data models, and then what is data model, what is the purpose to build data models, what are the different types of models, what benefits we have. And to start with, we'll have a requirement analysis, like how requirement analysis is very important, and we'll do a small case study which will tell us why this requirement analysis is so important for starting a data modeling activity. So what has happened, like in the last decade or so, the technology has changed very fast, and because of the change of technology, there has been a lot of innovations in product, technology, and processes. So because of that, there is a massive amount of data which is flowing today in the current industry. Okay, so there is a need to manage all this information. So because of all this, there is a need to manage this information. So when we think about managing the information, I mean, can you imagine you directly build a house without a map? Can you imagine you directly go out designing machines without having your or 3D diagram built of machine? You can't do that. So similarly, in IT systems also, you just can't think about managing vast amount of information if you do not really have the data models in place. So this is why we need a data model. So you just see, I mean, the points are written here, like you want to coordinate and build a house without a plan. Like you really can't think of that. If you do not have the complete picture of the requirement, you just cannot go about in telling like what material or what resources you need. So similarly, in our industry also, if you do not have a model at place, you really do not know what are the requirements, right? You really do not know what can be the future needs of the enterprise, which you have not taken into consideration. So it is very important for us to really understand and analyze what are the data requirements. So analyzing and understanding the data requirement, data modeling is a step which help you to communicate with the different users, to the business stakeholders, in terms that we correctly understand what they need, to the IT users, wherein we can really communicate with the IT users and tell them what they have to develop. So data model helps us to communicate with all the different stakeholders in an IT setup. Okay. So I mean, this is just like information modeling. There are a lot of things in information modeling. You have logical data model, you have conceptual data model, then you have normalization techniques for your third, I mean, EDW that you design. Then you have dimensional modeling, which you usually use for semantic modeling, which you do it in your MicroStrategy or any reporting tool to expose it to the front end over which the reports are built. Okay, so to start with data model, we will try to first understand the analogy. I mean, I'm just trying to give you an analogy to explain you what a data model is. So data model is nothing but it's like a blueprint. So you see a map, right? If you go to a railway station or that, you will see a map. Like if you go to any metro station, you will see a map which says that okay, this train goes from this place to that place. So with the help of map, you really understand what is the route that you are taking. So similarly, a data model within an enterprise, it helps you to really understand how your information framework is. It is very powerful, which gives you the foundation of what your information requirements are, what information your enterprise holds today. So if I give you an analogy, a data model is very similar to what a map is. And other things that I can tell you about data model is like a model can be a set of symbols and text which mix and helps you to understand a very complex business problem. So if you really want to express what the business problem was, you can use the data modeling techniques, and using that technique you can communicate with the outer world and tell them what this problem was. So for example, an organization chart. So these are the different flavors of model. An organization chart helps an employee understand the reporting structure. A blueprint helps the architect to communicate the building plans. A map. So these are all different forms of model. So if I come down specifically to data model, then data model uses symbols and text. Developer and analyst better understand what are the set of data elements are and what is the business rule between those data items, between those data sets. So it really helps you to improve the communication level within the organization, and it helps you to build a more flexible and a scalable system. So similarly, I said, like I have said all this, so it is there in the slide now. So what is the purpose of data model? So if you see on the right hand side, it's a map of a building. It's a visual representation. It is just like that a building map is there. So similarly for data, you need a map at place which will tell you what are the information it has, and it helps you to communicate between different groups which are there in your IT setup, and it helps you to have a common understanding of all the important business concepts. So for example, if I tell you, you go to a bank and you open an account, right? So when you open an account, you sign some agreement papers. That is nothing but a contract. So in the IT world, the same contract can be called it as agreement, or maybe a different department may call it as arrangement. But if we have a model in place, then we can map all this concept to one subject area which we can call it as an agreement. So through a business concept, we can say that all the different departments have come to a conclusion and they have a common understanding. So this is one of the other use of a data model. This session is just to give an introduction and show you what are the things available in the data modeling world, what this world is all about. So I want you to introduce you to all the concepts, and through our later sections as a part of course we will get in and touch in most of the concepts. Okay, so into the data modeling phase and data modeling world, you will find all these terminologies very frequently. Conceptual data model, which is CDM, logical data model, which is LDM, right? And then physical data model, which is your actual table structures in your database. And then your semantic model, which is nothing but your model which will support your reporting requirements, which is nothing but a dimensional model, or the MSTR architect models that you create in MicroStrategy. You would have done that. So that is nothing but a semantic model. So what is a conceptual data model? At a very high level, if I tell you, I want to explain you in a particular business process, what are the high level entities, or what are the high level subject areas within those subject areas, what are the high level entities and how those entities interact with themselves. So at a very high level, if I want to give that picture, then that is nothing but a conceptual data model. The logical data model is when you design an application, or typically a reporting application or an OLTP application or a data warehouse, you will have some information requirement at place. So when you map those information requirements into the entities within the subject area, and then you define the business rules with the way the entities interact with themselves in a particular business context, then your logical data model is built. In logical data modeler, you take key decisions in terms of defining a primary key, in terms of defining foreign keys, right? In terms of what would be the relationships, cardinality. So all these decisions are taken at the logical model end. And in the physical model, on the basis of the target structure of the physical structure, if it is an RDBMS, what RDBMS it is, so you will consider the other requirements in terms of performance, scalability. So all this taken into consideration, and you design a physical structure, right? And you provide a set of details which will create the physical structure in a database. So that is nothing but a physical data model. In logical data model, you will have lot of parent-child relationships which will be super type and subtype, right? The super type and subtype is, for example, if I give you an example, a person can be an employee, and the person can be a customer. Okay, I'm just giving you a scenario. So person is super type. Say now the same person can be an employee, same person can be your customer. So how do you want to design this? You want to design one table as person, or you want to design 3 different tables? So that is the decision you take at the physical model. Okay, if you decide no, I just need a person table, and I will have a flag which will help me to identify whether it is an employee or whether it is a customer, then what you will do is from logical model to physical model you will transform and roll up all the child entities to the parent entities. So this is a design decision that you will take in a physical data model. And the other decision that you take in physical data model is typically what audit columns you will have. Right? These are the decisions you don't take it at the logical model. From a database perspective, what indexes you will choose. So all this decision of indexing, what indexing you are going to choose, or how many tables you want to merge, or if you want to create, split one table into different tables. So all these decisions are taken at the physical model. So you will have that physical model in Erwin where you will take all these decisions, right? Yeah. And semantic model is, it's another separate model which is created just considering your reporting requirements in hand. So this is nothing but it can be created in Erwin. It can be created in any reporting tool, like for Cognos, you can go in Framework Manager and create this model. You can create it in BO Universe, Business Objects Universe Design. You can create this model in your MSTR Architect. So this is nothing but the reporting layer model which will be exposed for your reporting layer. Okay. So this, in data modeling space, you will not have anything more than this. Now business view. When you create a data model, it is very important. A data model is useless if it is not signed off by the business. So when you create a data model and when you go to the business, he might not understand what entity, what relationship. He will not understand all the IT concepts, right? So for him to understand, you need to have a business translation of your logical data model. So you will try to represent that logical data model into all the business names and business concepts, and you will see how these concepts are related with each other. And that is how your stakeholder will understand of how exactly you have understood the requirement or not. And on the basis of that, your sign-off becomes pretty easy. And that business view can also be used in your semantic layer to create your semantic model. So now if you see, these are some benefits of having a data model in place. Like it helps you to have a single version of truth. It gives you the, documents, critical documents that you want to prepare, logical to physical and all those. So it helps you in data quality management. And then if you want to develop if you want to start a new development, how do you start it? You first need to understand what is the existing system, right? So that if you are trying to extend it, you map it correctly and you map the correct business concept at the correct place so that the extensions becomes easily. For example, today you have a customer data. Tomorrow you want to bring in employee data. So you have to, if you have a logical model in place, you will map your employee to your party subject area. If you do not have a logical data model at place, you will never be able to map correct business concepts at the correct place. So this will always help you to have a more stable database structure, and your design will be very good, and it will be easy for you to carry out the developments. Okay. Now, the very important step, in data modeling, the most important step is to correctly understand the business requirement. So here I will do a small case study wherein I will tell you and show you what is the importance of requirement analysis is when you do a data modeling. Right. So these are some write-ups like why business analysis is so important in a data model. See, at the end of the day, the end result is a physical table. So the question should be, why don't we just design tables, right? Why do you do a logical data modeling? You should have this question, right? Big data coming in, you don't even design a database. With no SQL databases coming in, you don't have to design any database. You just go and dump the data. Then why do you need data modeling, right? So these are some questions to be answered. Here is zero answer. If you do not really understand your requirement, what problems you may get into. So to correctly understand the requirements, it is a responsibility of a logical data model to ensure that your business understanding is correct, alignment is there, you have a complete, accurate and complete picture of what the data you have, right? So what does it look like? So I just want to show you a small case study. For example, now you just consider any retail company. So a typical any retail company which is on working globally. So suppose it works in North America and Europe. So the process of order should be same. You have order, delivery, shipment, and it is same in Europe. But now you see what is the concept of delivery in Europe and what is concept in North America. So if you see here, I'm just trying to show you a business case. So see, in Europe and North America, in creation of a package for an order, it is, for example, says to leave Unilever distribution center. In Europe, this package is given to the carrier and everything is assumed to okay, and the customer, unless losses are received, is back. So in Europe, the concept is different. In North America, proof of delivery is required through the shipment information. So for the same company, the process of delivery and shipment is different in different geographic regions. So you will only come to know this until and unless you will not do a requirement analysis. So here is where a business analyst role comes into picture, who helps you with all these typical block diagrams. So now I have a small case study now where there is a requirement. Now, for example, both the regions use same ERP module, right? Now you have one ERP module which is installed for order capturing of both the regions. So here the requirement analysis is so important. If you see, the data capture for order fulfillment at different source is different. I showed you, right? In North America the concept is different and Europe the concept is different. Okay, so here in North America, if you see the planned delivery time, the planned delivery time is recorded as required delivery time. That is the actual delivery recorded later from shipment. I mean after till the time shipment is done. And in Europe what happens? The same planned delivery time, the same concept is recorded as actual delivery time, right? So here in Europe the concept is assumed by business the delivery will occur as planned. I mean North America believes only after shipment is done. Europe says if the delivery happened, that means our delivery is done, right? If the planning is done. So now a new requirement has come up. So now there is a new requirement where you need to modify the model. So if you don't really understand the requirement, see the problem that you will face. At first glance, now the requirement is to add request delivery time. So if you see at the first glance, to confuse is what America called required, but they are not the same. New requirement is to record the time requested by the customer. It is a requested delivery time. So it is a time requested by the customer. See what I'm trying to tell you, there is a new requirement where you want to add into your database a new field as requested delivery time, right? So if you see, you have a requested required delivery time, right? So the delivery time looks very similar to your America requested delivery time if you just go by field name. So my idea is, with this example I want to tell you is that if you do not interact with the business user, or if you do not understand what this requested delivery time is, what you will say is that okay, the requested delivery time is same as required delivery time and then there is no database change. But they are not the same, because the new requirement is to record the time requested by the customer. This required delivery time is very different from the time. So the definition of both the fields are different. What I'm trying to explain you is the definition of the same delivery time is different in different contexts. Okay, so this will only come to know if you do a very thorough business requirement analysis. So if you see, I just tried to show here that these were the 5 additional requirements, right? Column to be added. So if you examine all the elements of the sources are for various delivery times were required, right? And there were differences and details for the requirement. So at a glance, if you see, you may feel that no, all these things are there for America requirement and everything will meet. But actually that's not the case. So in that case, you will have to add all these 5 new columns. So all these confusions can be solved if and if only you have a clear picture of your requirement. So you need to have this clear picture of the requirement. So here what I have tried to cover you is, I have told you the need of data models, what data models are, what is the purpose of it, what is the role of data modeler, what are the different development process in a data modeling, and we have discussed the business requirement analysis to be done in data modeling and what is the use of it through a case study. So that was it for today.